y'all. We're going to spend another day on partial fractions. I'm just doing another example with you. And this, we're 7-5 day 2. It says this will be our most laborious problem. I think it's going to be our most fun problem. And some of you might argue that that even though this is going to take a lot of work, the one where you had to do long division was probably the most maybe the most laborious. So we all have our own opinions. Okay, so let's try to turn this complicated rational function into the sum of, and I think I'm going to say 3 fractions with linear denominators. So this is going to be x minus 1, this is going to be x plus 2, and x minus 2. 6x squared minus 8x minus 4 over the factored version. So 3 linear factors, so I'm going to need 3 constants in my numerator. So the first fraction is going to need an x minus 2 and an x minus 1, right? I don't have to write that every time. I hope you can kind of keep that straight in your mind. It's going to need an x minus 2 and an x minus 1. The middle one is going to need an x plus 2 and an x minus 1. The last one is going to need an x plus 2 and an x minus 2. Once our denominators match all the way across, then we are going to focus on the numerators. Okay, and the 2 that I put with A are x minus 2 and x minus 1. The 2 I put with B are x plus 2 and x minus 1. And the 2 I put with C are x plus 2 and x minus 2. And it doesn't matter which variable you work on first, but the good thing is each one of these linear factors kind of like overlap into 2 being in with 2 of the constants. Okay, so let's say we want to work on A. There's a number that we can choose for x that'll wipe out this one and this one, and it's going to be negative 2. So I'll let x equal negative 2 first. And I'm not even going to write these 2 because I know that negative 2 wipes them out. So I'll just stick with that. Positive 12. I got A to be 3. We can work on finding b next, so I'll let finding b, what's going to make those disappear? Positive 2. Got b is 1. And let's work on finding c. So I want x to be positive 1. Okay, where was I? What were we even doing? Oh yeah, we are going to do an antiderivative on that huge rational function. So now let's do an antiderivative basically on each individual piece. 3, 1, and positive 2 are my constants on top. I think you like the fact that none of these have a coefficient, so those are going to be pretty easy antiderivatives. And I think by now most of you can just, in your head, pull the 3 off and do your antiderivative, which is going to be natural log. So I've got 3 ln absolute value x plus 2 plus 1 ln absolute value x minus 2 plus 2 ln x minus 1 You can even condense them. You can ln this. Okay, hang on. Before you condense them, this would have to go on top as an exponent. So you'd have this binomial cubed times this one times this binomial, and this would have to be an exponent. So I could do ln Either one of those answers is fine.